Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. At the center of the Milky Way lies a cosmic giant, a supermassive black hole, Sagittarius A, or Sgr A for short, with a mass over 4 million times that of our Sun. It's the invisible anchor around which our entire galaxy revolves. But despite its enormous gravitational influence, Sgr A has long appeared quiet, at least compared to its more active cousins in distant galaxies. Now, thanks to the Event Horizon Telescope, EHT, and an extraordinary new set of observations from 2024, that picture may be changed. Astronomers have discovered evidence of a faint, possibly long-hidden jet, an energetic stream of particles emerging from Sgr A star. If confirmed, it would be one of the most exciting discoveries about our galactic core in decades. Polarized light, powerful insights. The breakthrough came when the EHT team, a global collaboration of radio telescopes linked together to form an Earth-sized observatory, released polarized light images of Sgr A. This imaging technique, which reveals the orientation of light waves, is especially useful for studying magnetic fields, the invisible forces shaping how matter moves near black holes. To the researchers' surprise, the pattern of polarized light around Sgr A resembled that of Mighty 7, the supermassive black hole in galaxy Messier 87, whose iconic jet was famously captured in EHT's first ever black hole image in 2019. Like Mighty 7, Sgr A star appeared to possess an ordered magnetic field aligned along a specific axis, rather than a random, turbulent field. This alignment is often the signature of jet activity. Although no visible jet has been directly imaged yet, the presence of aligned magnetic structures and subtle radio emissions strongly hint at a weak, slow-moving jet trickling out from Sgr A star, possibly pointed away from Earth, or too diffused to be seen with existing instruments. This ghost jet may have been hiding in plain sight all along. What are black hole jets? And why do they matter? Black hole jets are among the most powerful structures in the universe. They're created when magnetic fields around a black hole accelerate particles to nearly the speed of light, flinging them out into intergalactic space. These jets can stretch tens of thousands of light years, shining brightly across the electromagnetic spectrum. Most black hole jets are associated with quasars and active galactic nuclei, galaxies whose central black holes are devouring matter at a furious rate. Sgr A star, by contrast, consumes relatively little material and has long been considered a dormant black hole. But this new evidence suggests that even a quiet black hole like ours can launch a jet, albeit a low-powered, intermittent one. That revelation changes everything. It means jets aren't just reserved for the most active galaxies. They may be a universal feature of black holes, turning on and off depending on magnetic structure, spin, and the surrounding environment. Sgr A could be a scaled-down version of the monstrous engines at the heart of distant galaxies, a local laboratory to test big cosmic questions. Connecting the jet to the Fermi bubbles. In fact, the idea of a jet from Sgr A star isn't entirely new. For over a decade, astronomers have puzzled over strange gamma-ray structures called the Fermi bubbles, massive lobes of high-energy radiation extending 25,000 light-years above and below the galactic plane. These bubbles, discovered by NASA's Fermi Gamma-Ray Space Telescope in 2010, have remained a mystery. Some proposed explanations include past explosions of star formation, or outbursts from Sgr A star itself. But if a jet has been active at the center of the galaxy, even intermittently, it could explain the geometry, energy, and alignment of the Fermi bubbles. A faint jet interacting with the Milky Way's gas and dust over millions of years might have inflated these giant lobes, pushing material outward like smoke from a galactic chimney. It's a tantalizing idea, and one that brings Sgr A into a broader cosmic context. Suddenly, our black hole doesn't seem so quiet after all. Why we haven't seen it until now. So why has it taken this long to find? Unlike mighty 7 star, which sits in a relatively open part of space, Sgr A is buried behind clouds of dust and gas in the center of the Milky Way. Observing it, it is like trying to see a match flicker behind a curtain. Earth's atmosphere, cosmic interference, and even the variability of Sgr A itself have made it notoriously difficult to study. Sgr A star answer changes on timescales of minutes to hours, compared to days to weeks for mighty 7, making it harder to get stable data. But by capturing polarized light and coordinating across the globe, the EHT team overcame many of these challenges. The results don't show the jet directly, but the clues are stacking up. Magnetic alignment, radial lobes, axial structure, and now improved simulations that suggest jet-like dynamics. If future observations confirm even a low-power outflow, it would be a watershed moment in black hole astrophysics. The bigger picture, black hole unity, Sgr A, has always been a benchmark. It's the closest supermassive black hole to Earth, offering an unparalleled opportunity to test Einstein's theory of relativity, study black hole accretion, and model how galaxies evolve. Finding a jet here, even a faint one, would mean the mechanisms that govern quasars and active galaxies also apply right here in the Milky Way. It supports the idea that all black holes might operate on a universal set of principles, scaling up or down depending on their size, spin, and feeding habits. It would also reinforce the role of magnetic fields as a key ingredient in launching jets, a topic still not fully understood in modern astrophysics. What evening? Astrophysics. Just as EHT's 2019 image of mighty 7 star changed how we visualize black holes, these new findings could change how we categorize and compare them. What comes next? Future campaigns from the EHT will attempt to directly image Sgr A, especially as techniques in very long baseline interferometry, VLBI, continue to improve. Observatories like the next generation, EHT, and the Square Kilometer Array, Sgr A, may one day produce real-time movies of jet evolution. Meanwhile, multi-wavelength observatories, from Chandra and Sexem Newton, X-ray to Alma and Meerkat, radio, are helping triangulate Sgr A star's structure in 3D. Each layer of data paints a sharper picture. The biggest hope? That one day, we may not only confirm the jet, but watch it change in real time, giving us a live view of the Milky Way's beating heart. Sgr A star was once seen as a sleeping giant. But now, thanks to cutting-edge techniques and global collaboration, we're realizing it may be stirring after all, sending out whispers of ancient activity, magnetic memory, and hidden power. If there's a jet, even a faint one, it would mean our own galaxy participates in the same dramatic cosmic physics as the brightest galaxies in the universe. And that's the beauty of modern astronomy. We're no longer just looking out at distant monsters. We're starting to realize we've been living next door to one all along.